Hello, my name is Avery Hutchinson, and this is my final lab for Physics 1. The purpose of this lab was to model a ball moving in a vertical path while connected to a spring in the center of the start of its circular motion, in order to graph the energies of the ball and spring system as it moved through a not quite circular path. The fundamental principles and ideas are ones that I've seen before many times this semester. The concepts of the force of gravity and spring force are used based on my defined system, and Newton's second law helps connect them to the overall motion of the system. To further explore system properties, system energies are also important to define. So, my system was the ball and the spring, and my surroundings were the earth. You can see my initial ball position, ball velocity, relaxed spring length, and spring constant, which are what I consider to be my initial conditions. So I made a few assumptions in order to actually be able to build my model. For one, I considered no rotational energies or rotational motion. The inclusion of torque, angular momentum, and rotational energies would complicate calculations without changing the path of motion significantly. Additionally, I considered Earth not to be in my system. This is because the system has no defined height relative to the surface of the Earth, so it would have been difficult to include calculations of gravitational potential energy. Thus, keeping it out of the system simplified calculations. Finally, no internal energies other than spring potential were considered. Since this model is not based off a real experiment, there were no ways to measure, observe, or easily model changes in thermal energy or other changes in internal energy, so their inclusions would have made calculations more difficult. Generally, the motion matches the intuitive ideas about what a ball spring system would look like vertically. The total system energy, which was made up of kinetic energy and spring potential energy, is not constant. This is probably due to the work done by gravity and possible system energies not considered changing. Here's the first part of the code for my lab. As you can see, we define our initial conditions, define the direction of the spring, and then go into calculating the force and how that is impacting the ball's motion. And then I use that updated motion to calculate the changes in the system energy. So here's the model that I developed. Here are the energy, x position, and y position graphs outputted by my code. So what are the differences and errors that we would see? The total energy of the system isn't constant. This can be accounted for by the work done by gravity and the fact that other possible system energies, such as thermal energy, kinetic rotational energy, etc., could be relevant to the system while not being considered here. Additionally, I did not consider certain forces that may impact the system, such as drag force, because I wanted this to be a widely applicable model. Additionally, I only considered one specific starting position, velocity, and spring. Thus, the energy graph and predicted trajectory is not widely applicable past this experiment, and a case-by-case usage of the model with varying star condition would have to be used. So what if? If the ball had a greater mass, the ball's oscillation will be shifted downward due to a greater downward acceleration due to gravity. Additionally, it would have increased the period of oscillation, meaning that there would be less curves in the final trajectory. Finally, there will be a lower amplitude of motion in the x direction, as the spring's displacement will be more in the y direction than the x direction, meaning that the spring force will motivate more vertical motion than horizontal motion. What does it mean? Does the model violate the energy principle? Short answer, it's hard to tell. From the graph, we can see the total system energy is inconstant. This can certainly be mostly explained by work done by gravity, but this is probably not all the change. However, there are many internal system energies that could be relevant that the model does not account for, which could account for the rest of the error. Additional forces like drag force could also be impacting our system. Thank you.